Hello students, welcome back. Our game is complete. Crossfire is fully playable and pretty darn fun. We can move around the battlefield dodging projectiles from enemy turrets that spawn all over. We can use our overdrive system to protect us and then drain it and restore it whenever we get a pickup. But at this point, we have one more lesson that we're going to do. Even though our game is done, we're going to make it just simply better by adding some game polish. Our polish that we add is going to make our game visually more engaging, more fun to just play, look at, and interact with. And we're going to implement 3 polish systems here. The first is going to be a particle system. Anytime our turrets fire a projectile, we're going to spawn projectiles at that turret that fire out in all directions, giving more visual appeal to the game. Our second system is going to be an overlay that we draw anytime our overdrive destroys one of those projectiles. So anytime we use our overdrive system and we protect ourselves from an incoming bullet, we're going to have a flash effect on the screen. And then our third polish system, that overdrive shield, which is currently just a static circle, we're going to make it pulse and grow and shrink anytime we use it. So these 3 things will take our game from being playable to being fully enjoyable. So let's head to the computer screen and dive right in. All right, so I have Lesson 8's starter file open right here. I'm going to minimize vscode.dev, and I'm going to open up that file directly in my browser as well, so I can see the changes that we are going to make to this game. All right, so here is the current state of our game. Let's take a look. All right, I think this is just our playable game, right? No polish implemented yet. So there's no particle systems. If I absorb a bullet, there's no flash on the screen, and you can see my overdrive shield is pretty static right there. It's not pulsing like I want it to. So we got quite a bit of work that we are going to do here implementing our game polish. So let's look at mission number 1. The first thing that we're going to do is we are going to define our polish constants. So I'm going to hit Control F to open up my search bar, and I'm going to hit down to go to the second tag of mission number 1, our polish constants. Where do all these polish constants live? Look, we got some for particles, for our shield flash, and our shield pulse. They live in our student edit zone, where we can tweak these parameters to change our gameplay. So we're going to tweak them right now. Let's scroll down because look at, they're all set to 1. Those are terrible values. We gotta fix that. So I am going to put in some values that I've tested that work for me, but as you're playing your game, come back to this section and change these values and see what you like. You have the freedom to do that. It's not going to break anything in your game, which is awesome. So particles per turret fire. So anytime a turret fires a bullet, how many particles am I going to create? I'm going to create 12 of them, and they're going to have varying speeds. So every single particle is going to have different speeds. So it sort of will look like almost like a firework effect. Some will move fast, some will move slow. And the range of speeds that I'm going to have is, let's do 80 pixels per second to 250 pixels per second. And then they're also going to have a lifetime, all right? So what's going to happen is when our particles are created, we're going to draw them with an alpha of 1, which means they're not going to be transparent at all. And then we're going to fade that transparency down so that they're going to be, you're going to be able to see through them, see through them, and see through them until they just simply fade away. And we're going to do that based on their particle life. And I'm going to have them live for a half a second, 0.5 seconds. And then we need a particle size. I'm going to set that to 6. Okay, so that's how big they're going to be. So that's going to be our constants for our particle system. Let's talk about the other constants for our overdrive, our shield. So the shield flash duration in seconds. We said that anytime our shield actually absorbs a projectile, we're going to flash an overlay to the screen, and it's only going to last very shortly. We don't want it to last long, so I'm going to set it for 0.12 seconds. All right. And then our pulse speed and pulse amount. When we run our overdrive, right now it's just static. I want it to pulse in and out, in and out. We're going to kind of like animate it. So the speed of that pulsing, I'm going to set to 12, and the amount, or how large do I want the pulsing to be, I'm going to set it to 3. All right. So those constants are set. You remember, there's 3 parts here. We got to define the data, update the data, and then draw the data. So we are defining that data. In fact, we got to define it a little bit more because while we initialized it right there, anytime our game resets, in our reset game to defaults function, which we have right here, we want to make sure that we set those to their starting values. So let's just go back up. I should probably go up a little bit because we have some gameplay variables here right outside of our student edit zone. And here's where we defined like our array for our turrets and our projectiles. We defined our player object. And if you look, we've got 2 more things. We've got an array for all of the particles that are going to live in our game. And if you think about it, when one single turret fires, I'm creating 12 particles. And I am going to have, I think I have 5 turrets. So, I mean, what's 5 times 12? 60. So at any point, I could have like 60 particles that are all going to be living inside of this array. And the power of this is that I can loop over this array and call operations on every single particle that is inside of this container. I also have a shield flash timer in seconds. It's currently set to 0. That's probably a good thing because eventually what we'll do is we will set it to our shield flash duration and then we'll drain it. All right, so I think that that's going to work really nicely for us. So we got to make sure that these things are set correctly when we reset our game. And that is mission 2. So right here in mission 2, let's target the particles. Let's target the particle array first. So we're going to say particles. If there's a bunch of particles on the screen, we're going to get rid of them. We're going to empty that array out and redefine it as an empty array. Also, we're going to take the shield flash timer in seconds, and we're going to make sure it's set to 0 because when we restart the game, we don't want that flash on the screen immediately. So we're going to set it to 0. Very good. Mission number 2, done. Well done. Well done. All right, we are still in the data generation. So we have defined our constants and set them for a game reset for all of our polish systems, the particle system, the overlay flashing system, and then the pulsing system of our overdrive shield. So now we're going to focus on the particle system. So what we're going to do here is we are going to look at the generate particle data. Now, hopefully you've recognized a bit of structure here. Look at what we have when we are creating particles. We have a function that generates the particle data. We have a function that spawns the particles, and we have a function that updates the particles. This is extremely similar to what we did for, let's just see, our pickups. We had an update, a spawn, and a generate. For our, let's see, projectiles, we had an update, a spawn, and a generate. For our turrets, we had an update, a spawn, and a generate. That's the general convention that I use. Anytime I have to introduce something into my game world, I'm going to use 3 functions to do that. We're going to generate the data, we're going to spawn the data, we're going to update the data. So let's go and generate the data for a given particle. Now, before we get there, look at what we have to take in. We're taking in the turret that we are going to generate the particles at. Because like when this turret fires, I want to make sure that I'm generating the particles right here and they shoot out in all directions. It would be super weird if this turret fires and the particles like appeared over here. So we got to have a reference to the turret that is creating the particles. So I have that turret. And in fact, really quickly, let's nail down our particles X and Y properties. So this is going to be the particle that we create, this object. And it's got a ton of properties, X, Y, VX, VY, life seconds, max life seconds, and then a color. So we have to lock those properties in. So our X position, we do not want to spawn at X position 0, Y position 0. That would be like all of our particles start up here in the top left corner. Instead, I'm going to take the turret that was passed in. And if you remember, it has an X property as well. So I'm going to take its X property. And I will take the turret's Y property as well. Awesome. Now, we've got to set VX and VY here. This is going to require us to use a couple of constant variables that were created up here. So if you look here, we're defining an angle and we're randomly selecting something from 2 pi. 2 pi is 2 times pi, 3.14, right? And these are known as radians. And we're going to talk here about radians in a moment, but we're randomly selecting the angle at which our particle is going to get created at. So maybe our particle is going to move off at an angle that sends it this way, or this way, or this way, or this way. And we're going to have 12 different angles for 12 different particles every single time we fire. And Every particle is also going to have a random speed. And we're going to use the random function here to pick from our minimum speed of 80 and our maximum speed of 250. So one particle might move that fast and one might move that fast, so a little bit slower. And this is going to create that firework effect that we're looking for. So how do we use these two values to give us the random motion that we are looking for? Well, we somehow have to apply them to Vx and Vy, the horizontal speed or horizontal velocity and the vertical speed or vertical velocity. So to help us with that, we're going to go to the whiteboard. We're going to do a little bit of math, just a little bit, I promise, not a lot. So let's maximize this. Zoop. That's not maximized. That's maximized. And let's take a look here. So imagine here is my turret. Zoom. And there is the center point of my turret. And I'm going to create a particle. And I want to send this particle out. So maybe I want to fire out this particle. Let's see, what direction do I want to fire it out? I'm going to fire it out at this direction, okay, just like that. So that's the direction I want that particle to move. So I'm going to draw a triangle over here that is going to show that kind of blown up. So that is the direction, okay? The direction we want the particle to move. How do I get that direction? Well, that direction points up into the right. And so we can get it by thinking of this arrow as having a rightward part, zoop, right here, and an upward part right here, zoop, and it forms a nice triangle. And we can define an angle right here. And that angle might be somewhere between 0 and 2 pi radians. Now, in order to get the x part, the part of this direction that points in the horizontal direction, we have a nice trig function for us. So I'll call this like the x part, right? The x part. The x part is going to be using the cosine of our angle. The cosine of our angle is defined as the adjacent side to that angle divided by the hypotenuse. All right, so if we look here, the cosine of our angle is going to give me adjacent over hypotenuse. And if we want the opposite side, we look over here. That opposite side, the vertical part, is defined by a trig function known as the sine of theta, which is opposite over hypotenuse. Now, if we look, those values, cosine and sine, will change as the angle changes. So now imagine if I have a different one and a different projectile, boom, and I'm going to fire it at a different angle. Maybe I'm going to fire it sort of like this way, up this way. So now let's look at what this triangle might show. I want to just move that. There we go. So let's make another triangle. So now if I make a triangle for that arrow, right, now my direction is sort of like up this way. All right, direction. You can see, how does the x part and the y part change? Well, now the x part is a little bit smaller. All right, so the x part is smaller, and the y part got bigger here, and the y part got bigger, and that's because the angle changed. So if I look at the cosine of my angle, all right, the cosine of my angle is going to be the adjacent side over the hypotenuse, and the sine of my angle is going to be the opposite side over my hypotenuse. The truth is, in these diagrams, direction is going to be equal to 1. Direction is equal to 1. So the hypotenuse is never changing. What's changing is the size of the adjacent and the opposite sides, the size of the x and the y. When the angle gets bigger, the x component is getting smaller and the y component is getting bigger, so the sine of that will change. The cosine of that will change. And we're going to use cosine here to get the component of our direction that points in the horizontal, and sine to get the component of our direction that points in the vertical. All right, so that's the end of my math talk right there. Let's apply this here. So right now, I'm going to say, okay, so Vx, let's use the cosine. So we have the cosine function of the angle that we generated. We're generating an angle right here. Now you can also do sine and cosine in degrees, but we are using radians because the function here requires radians. And then lastly, we'll do Vy as the sine of our angle. Okay, so that I guess is good, but there's only one problem. Like, we don't want the velocity to be just the cosine of our angle and the velocity here to be the sine of our angle, because sine and cosine, they're like decimal numbers between 0 and 1. This is just the direction that the velocity is pointing in the x direction. We need to somehow take that and multiply it by how fast the particle is moving. And so if you look here, we have a variable called speed, right? Every particle is going to have its own speed. So we're going to take the direction, how much of its speed is pointing in the x direction right here, and we're going to multiply it by its speed. And then we'll do the same thing down here. We're going to multiply by its speed. Hey, I think our particle generation is complete. Let's just quickly look at what else our particle has. It has a life seconds property and a max life seconds property. And those are set to that constant variable we had looked at, particle life seconds, 0.5 seconds. 0.5 seconds. And so what we're going to do is we are going to take this, and every frame of our game or every time interval, we'll decrease our life in seconds. So that will go, and when that hits 0, our particle is dead. And we're going to reference the max life that we have to make sure that we're changing the transparency of the particle accordingly. All right, mission number 3, done. So we've defined the data. That looks really great. What's the next step? Well, we've got to update the data. So right now, let's just see what happens if I refresh my game. Do I get any particles? Whoa! They're sort of going. Look at that. That's kind of neat. But they're all moving horizontally. That is not right. I don't know what in the world. I don't know. It kind of looks cool. It's sort of a neat thing. But yeah, this is bad. This is not what we want. So we got to go to the update. So let's look at our update. Right now, they're only moving horizontally. They're not fading out. The system is completely broken. So in update particles, it looks like we're looping through our entire array of particles. And we're using that structure where we're looping using let I equals particles.length minus 1, I greater than or equal to 0, I minus minus. Remember, we use that structure when we want to remove things from the array. All right. If we're not looking to remove things, we can just say like for const particle of particles. But here we got to be a little bit more specific. So I reach into the array at the given position, at position I. All right. And I define that given particle right here. So now I have it to work with. And let's look at mission 4. It says we got to update and clean up the particles. Move the particles and remove them when expired. So right now we are moving them in the x direction. Look at this. Particle.x, its x position is going to equal its horizontal velocity times time. Remember that great physics relationship I had taught you about, that speed is nothing but distance divided by time. So speed times time gives you distance, how much we need to move. Well, we're moving in the x direction. We got to move in the y direction. So let's do particle.y plus equals particle.vy. We're going to target its vertical velocity here times dt. Hey, if we run this, now our particles should move both hey, look at that. They're getting shot out. And look at that. Everything is random. They're all different. But this but they are not dying. They're just going forever and ever and ever. We got to make sure that we're somehow getting rid of them, right? And so right now, there's a second part to this mission. We have to remove them when they are expired. Well, if you look right down here, we're asking a question. It says if particle.lifeseconds is less than or equal to 0, we are going to remove them. Particles.splice, right? The splice method removes something from an array of particles. And remember, when we defined our data, we said, hey, there's this max life seconds, or max life seconds. There's life seconds. What we want to do is we want to decrease this value, and when it hits 0, that's when our particles are dead. If you look, we're not decreasing that value at all. So that's the last thing that we have to do here in this mission. So I'm going to target that property, particle dot life seconds, and I'm going to decrease it. How much do I want to decrease it by? 1, 2, 3, 4, 6, 7. I don't know. I'm not sure. I want to decrease. Sorry about the 6, 7 joke. I apologize. It's just nature at this point. So particles dot life seconds, we are going to decrease it by dt. So we're going to decrease it by just the time interval that has elapsed. And now when we do this, our particles should die and be removed in about half a second. And look at that. That looks great. And they're fading out just the way that we want them to. So it looks like our particle system, let's check, is our next turret can create particles. So this is looking pretty good. All right. Now we got to work on our shield, right? We got to work on the shield polish system next. So the particle system, I'm pretty happy with it. Let's go see what mission 5 has us do. We want to trigger the shield effect. You know what? Before we do that, though, I just want to show you, because it's kind of a neat thing. I'm going to go to the particles draw. Where's my particle system? Particles, particles, particles. Yeah, right here. In case you are interested, our particles are fading. Why are our particles fading? Well, if you look here, for every particle, I define the alpha of the color that I want to use. That's the transparency. And the transparency is set here using a ratio of the particle's life seconds divided by their max life seconds. So when we create a particle, remember this was set to equal max life seconds. So this ratio is equal to 1. And so the alpha is essentially 1. And then as this decreases and gets smaller and smaller and smaller, this ratio gets smaller and smaller and smaller until it basically reaches 0 when the alpha is 0 and the particle becomes fully transparent, which is why the particles have this cool like little fade effect. You can see them sort of fading out. Otherwise, what would happen is they'd be present, 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 and then they just disappear when we remove them. So that's just a nice little effect. All right, let's go to mission 5 now. Let's work on our flashing, our overlay, our shield flash. So anytime our overdrive system is able to protect us and destroy a projectile, we are going to flash an overlay. So right here, we are in the check player projectile collisions, and we said, hey, is the overdrive active? If it is, did the overdrive just combine and hit one of the projectiles? Get rid of that projectile. And now we are going to show a flash overlay. So we have this shield flash timer seconds. It's currently set to 0. I don't want to do that. I want to activate our timer. So I'm going to set it to some number that we will then count down from. I could set it to 1, 2, 5, 10. I don't want to do that though, because this is stored in a constant. It is stored in shield flash duration seconds. What was the value that we gave that at the start of this video? Like 0.12 seconds. Wonderful. Mission 5 is done. But if we run this right now, I don't think we're going to do anything yet. Let's just check it out. Nothing. No flash. Why not? Because we got to do mission number 6. We actually have to draw the shield flash. So let's take a look. Mission number 6 puts us in the draw shield flash function. All right, and where is this getting called from? So if I just scroll up, let's look at our draw scene. It's somewhere. It's somewhere. All right, here is our draw scene. Oh, look at that. We gotta then work on mission 7, which is going to be our draw flash trigger. So we're not even calling this function yet. That's okay. We should probably write it first. So we're going to draw the flash and then fade the flash. So we want to fade the flash. Hey, this is really similar to what I showed you with fading the particles, right? Right now we have this alpha, this flash alpha that is set equal to 1. That's not really what we want. So what I need to do is I need to get a fraction here, a fraction that is going to have our timer, which is decreasing, so shield flash timer divided by the maximum amount that timer could have, which is shield flash duration seconds. See, when we just set the timer, these two things are going to be equal, and this is going to be set to 1, our maximum value, which means our overlay is going to be set to be the strongest. You're not going to be able to see behind it, and then we'll fade it out. We'll fade it out. Now, this is a little different because when we talk about transparency normally using RGB alpha strings, we use values from 0 to 1. But the way that I'm defining my color here is not with a string. See, I'm putting paint in my paint bucket, and these are using RGB values directly. So from 0 to 255, 0 to 255, 0 to 255 for the red, the green, and the blue. And that means my flash alpha also needs to be from 0 to 255. So I could multiply this by 255, and that's going to give me an overlay that you can't see behind it all and then fade it out. But I don't want to do that because if I make it so you can't see behind it at all, we're not going to be able to see the game board. So I'm going to set it to, I don't know, something somewhere in the middle. I'm going to set it to like 120 to start with. So it'll go from like, I don't know, what is that? Maybe like a transparency of like 0.4 to 0 as we go through here. All right, so that flashing effect is set, but we know that this isn't going to work because we saw that we're not actually calling this function at all. We got to go to mission number 7. We're going to trigger the shield flash draw event. And so this is going to happen right here in our draw scene function. So our overlays, right? So we're always going to draw a background. We're always going to draw our turret. We're always drawing our particles and our pickups and our projectiles and our player in our HUD. But our overlays, they are only going to be drawn if certain conditions are met, right? We're only going to draw our start overlay if the game mode is start. We're only going to draw our lose overlay if the game mode is lose. When do we want to draw our shield overlay? Well, we're going to check to see if the shield timer is greater than 0. So shield flash timer, if it's greater than 0, then that means, hey, the shield is active. Let's draw the shield flash. So I'll say draw shield. Oh, draw shield flash. There it is. And remember, we are decreasing. So we set this, and then we decrease it, and we decrease it, and decrease it. And so once it gets to 0, we'll no longer draw that shield flash. And each iteration, that timer gets less and less and less, which means the alpha is going to be drawn, so that we can see behind it more and more and more and more. Let's test this system out. All right, so here we are. I'm going to get hit. And look at that flash. That's really great. That's super cool. And that 0.12 seconds is just the right amount. I mean, let's be silly. Let's be fun. Let's have some fun with it. Let's change the 0.12, I don't know, to like 2.12. This is going to be ridiculous, and it's going to be fun and awesome. And then I'm going to immediately change it back. Whoa. Maybe you like that. I don't know. Maybe that's, but you can see, that's setting the, where was it? We set the transparency. I'm going to jump around here, and I apologize for that. I'm going to go back to my draw shield flash. See, remember how I said we set this to 120 because we wanted to be able to see behind it? Watch what happens if I set it to its maximum value of 255. It's just going to be a really terrible effect. Whoa, I couldn't see at all behind it. And I don't like that. Because who knows what's happening in the game while that's going on. So I'm going to set that back to 120. And then I'm going to go all the way back to the top of my program and set the duration back to 0.12. Because 2.12 seconds, just too long for me. Maybe it's right for you, but it's too long for me. All right, our shield flash is in place. The last thing that we want to do is we want to look at our pulsing. Because right now, when I call that shield, when I call my overdrive, it is completely static. That's not really what I want. I want it to pulse in and out. And so let's go to mission number 8. Mission number 8, in our draw player, we're checking, okay, we draw the outer body, we draw the inner body, and then we're checking to see if the overdrive is active. If it is, we draw the overdrive color, and we're just drawing a circle, right? We were drawing a circle. But now, look, we're adding something called pulse here. So overdrive radius plus pulse times 2. So this is the diameter of the circle that we're drawing. Well, right now, pulse is equal to 0. So when you add 0 to anything, nothing changes. Let's change it to something crazy. Let's change it to 100. So now if you look, when I draw this, whoa, it just got a lot bigger. Okay. And if I change it to, I don't know, 25, let's see, it's going to get smaller. All right. And then if I change it to, 1, it's going to get even smaller. So that's kind of the effect, right? It's going to start big, and then I want it to shrink, and then I want it to grow, and then I want it to shrink, and then I want it to grow. The only problem is I can't come back in here and constantly change these values. I need something that is going to change automatically for me. And so, unfortunately, or fortunately, depending on how you approach math, we got to go to the whiteboard. We got to learn a little bit of math because there is a math function that is going to help us do this. It is going to automatically grow and shrink for us. And that function is known as a sine wave. Now, we talked about sine, right? We looked at the sine, the sine and cosine earlier in this video and with these triangles, and we said, hey, these values are going to be between 0 and 1. Truth is, they could be between -1 and 1. So they could go from 0 to 1 or 0 to -1. So they oscillate or they go back and forth. And so what I'm going to do is I'm going to draw a nice sine wave. And I'm going to mark out some key points for me. I'm going to mark out 0. I'm going to mark out, let's see, pi over 2, pi, 3 pi over 2, and then 2 pi. All right, if you did not know this, I'll tell you right now. Let me switch my pen color so I get blue. I'm going to draw my sine wave, my sine curve. The sine of 0 is just 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. So I can draw a nice wave here. Zoop. as best as I can. I'll make that circle a little bit bigger. Now, a couple of properties here. First thing, this continues on and on. So instead of pi over 2, I could do like 5 pi over 2. All right. And this cycle just continues. It repeats, which is super nice. Now, there's a couple of properties that we need to know. First here is the amplitude of the wave, how big the wave is. All right. So I can have different sine waves. I could have something that has a much bigger amplitude. So maybe I'll grab an orange pen. I could have a sine wave that's like way up here, a lot bigger. The idea here is that the values constantly change. All right, that's the thing I want to get to. And I could also have a wave that is sort of smushed. So if you look here, in this range of 0 to 2 pi, I get one waveform. I could make something that's going to fit more waveforms in that region. So let me just say, I'll draw it over here so it's a little bit clearer. Right, here's 2 pi. Imagine if I had something that could fit lots of waveforms. So there's one waveform. There's 2 waveforms. And there's sort of like 3 waveforms. So this wave is essentially moving. It's sort of faster, but when we talk about that fasterness, it's actually something called frequency. So we have amplitude and frequency. And you can think of the equation for a sine wave as your wave is going to be the sine of x times a, where x is your frequency, how fast or how many waveforms you're going to fit into that period of time, and A is your amplitude, how big it is, all right, amplitude. And so we're going to use this here to create a pulsing effect. We're going to use the sine function to create a nice pulsing effect that grows, zoop, and then shrinks, zoop, and grows and shrinks. And grows and shrinks and grows and shrinks. And we can change the rate at the growing and shrinking, right? If we follow this curve, it's going to grow and shrink and grow and shrink. Or we could do it really fast. Grow and shrink and grow and shrink and grow and shrink. All right, so enough math talk. Let's come back over here and let's implement this. So we're going to take the sine function. All right, we're going to make that pulse value, which we were adding. We were changing it before, but now the sine function is going to change it for us. So the first thing is I'm going to put in the frequency, right? This is going to be the frequency of it. What is the rate of the growing and the shrinking? So the first thing I'm going to do is I'm going to set shield pulse speed. All right, shield pulse speed. So if we look here, that's 12. There's only one problem. That's a constant. I want that constant to vary, and so I'm going to create run time seconds times the shield pulse speed. All right, and so that's going to give us the frequency that we want. So as runtime seconds increases, this number is going to get bigger and bigger and bigger and bigger, and we will move along our sine curve. And then we're going to multiply by our amplitude. Our amplitude, how big do I want this to be? It's going to be our shield pulse amount. The bigger that number, the bigger the growth of the shield. And so now let's take a look. Oh, I got nothing here. Nothing. What did we do? Let's take a look. Pulse, sine, runtime seconds, times shield pulse speed, times shield pulse amount. I believe that is correct. Maybe it just didn't trigger. Let's try it again. Ah, there it is. Perfect. So you saw that nice effect. Now let's go up and let's change our parameters to see this in action. So if I change the shield pulse amount, let's make it to be like 10. Now let's make it, what was it? It was at 3, right? It was at 3. Let's do 10 times as big. So we'll make it 30. So now you're going to see it grow much larger. Yeah, you can see it grows much larger. If you like that, I'm going to, and maybe you say, okay, it's moving way too fast. Let's change this. The shield pulse speed, let's change this. We'll change it to 40. So now it should be going much, much faster. We're going to be fitting more waveforms in that 2 pi range. Yep, and look at that. For me, that's way too fast. Let's set it to 1. What's that going to look like? Oh, it didn't save it. I got to click off sometimes in order for it to save. Oh, well, that's just too slow. I think our original value actually worked pretty good. I'm going to go back to my original values of 12 and 3. All right, so our shield pulse system is in full effect. In fact, all 3 polish systems are here. We've got projectiles that are firing with particles spawning at the turrets. I have an overlay system for when I absorb a projectile, and my overdrive now pulses. It's got this nice animated effect. Oh, the game was playable before, but now it is extremely enjoyable. Oh no, I ran out of overdrive. Let's see. Perfect. And then, unfortunately, we die. Hey, congratulations. I think we have a complete, fully operational, and fun JavaScript game that we can play directly in our web browser. How cool is that? I mean, you could just you could show your friends, your family. You could play this on your computers, on your Chromebooks. Play it at school. Don't play it at school. If your teacher's teaching, don't be playing this game. But if you're, bored in study hall or during lunch, take out your Chromebook, show your friends. I think this is awesome. And the idea here is that it's so cool because you went through and took that terrible, sort of ugly, non-playable starting game that we had. Remember, it was like that mustard yellow background, and you brought it all the way to right here, this finished product. I hope you're proud of yourself. You really should be. And I hope that you learned a lot. And I hope that you'd consider learning a little bit more with me in another video. So I hope to see you then.